Plant Quarantine and Phytosanitary Service is one of the regulatory offices under the Ministry of Agriculture. The key mandate of PQPS is to prevent the introduction of plant pests. These are pests that are associated with commodities moving across borders. But apart from just preventing the introduction and spread of these pests, PQPS facilitates trade. And in this case, it issues trade documents that can ensure that whatever is moving across borders is in compliance with the phytosanitary requirements of a trading partner. So how do we do this as PQPS? PQPS, we've got a footprint at HQ here in Chilanga, but also we've got presence of plant health inspectors at the airport, KKI, and we've also positioned various plant health inspectors at various ports of entry or exit. That's the border.
Welcome to the Plant Quarantine and Phytosanitary Service, the Kenneth Audit International Airport Station. My name is Richard Mkua. I'm a Principal Plant Health Inspector in charge of international trade. So this is the gateway for most of the fresh produce that is earmarked for export. So the process basically starts from the place of production, where all the inspections during active growth are done. So basically in the field, what we do is we inspect for any live pests and anything foreign that we may observe in the fields, as well as conduct inspections at the pack house, which is situated at the farm where the production is actually being done. So whatever we observe in the fields, in the pack house, which is foreign or insect pests, we actually take those to the laboratories for identification by our experts in the laboratories. So we usually conduct frequent inspections in the field at the farm itself, as well as pre-export inspections before the consignment actually leaves for the destined markets. But one thing that we also need to note during our inspections here in the field is that the field they've installed pest monitoring facilities there. We've got pheromone traps as well as sticky traps. So as part of our responsibilities for our plant health inspectors when they go to the fields is actually to check the catches in the pheromone traps as well as the sticky traps, and if we need to confirm what those pests are, we have to go to the laboratory for confirmation of that. So whatever we do in the fields, all the inspections we do prior to export, we actually keep records. We write inspection reports. The producer keeps a copy, and then we also retain a copy which we file in our records for future reference as well as audits. So other than looking at the phytosanitary aspect, we're looking at pests and diseases in the field, we also ensure that the producer maintains a cold chain system to ensure that whatever is taken from the field, taken to the cold room at the pack house, we maintain a cold chain system as required by the phytosanitary measures that have been put in place by the importing countries. So once we are satisfied with the field inspections, the pre-export inspections, the cold chain management, and everything that we are looking for when we go for these inspections, we now proceed to issue a phytosanitary certificate, which is done through the Zambia electronic single window. So we have plant health inspectors who are stations at this station here who actually do that, but also the other inspectors stationed at the other PQPS stations can issue, because it's a web-based system. But for them to issue an inspection report has to be attached on the system, which shows that the produce that is being exported underwent inspections before even packaging was done and before submission of a request to export the commodity.
Our role is to formulate import conditions, and we also work hand in hand with the surveillance team to validate import requirements by other trading partners. So This is a very important section in the team, and we also respond to questions that we are addressed to us by our trading partners.
As pest surveillance, we carry out monitoring surveys to see and monitor the pest levels here. Apart from that, we also do detection surveys where we have to see which pests are present or absent at the production site. So that's the information that we use to validate or to also give advisory service to the grower, because where I'm standing here, there is this trap, and this trap is for Spodoptera exigua, and they also have another site where they're trapping Heliothis amigera. Then on the other side, there's also where we found that they are also having traps for Spodoptera frugipeda, which is the fall army one. So what we do with the scouting team, we come and count the trapped insect in here. So the higher the number of insects that are trapped here gives us a position to know that during the season the pest levels are high, and that also helps us in at early warning system, because we definitely know that if we're having so many adults at this particular time, meaning in the next 4 weeks to come we'll have a lot of larvae that will be ravaging our crop. So from there we can give advice that now they can come in with their the sprays, and those sprays also have to be sprays within the required levels and also accepted by the market.
One of the activities carried out under phytosanitary certification is field inspection of the crop during active growth. So as I'm standing here at York Farm Kashima, we have just been doing an inspection of the peas earmarked for export. So what we are doing during inspection of the crop in the field is to check for the pests of phytosanitary importance to our trading partners, and also any other strange pests we find on the crop. This is to ensure that the final produce, which is earmarked for export, is free of the pests of concern to our trading partners. And also, we conduct this field inspection to ensure that we identify the pests while they are still in the field and before they cause any adverse effects, so that we can also advise the grower on the remedial measures to be taken to ensure that the crop is free of the pests of concern.
Peas, basically, we've got two varieties of peas that we are planting here. We've got sugar snap and munch 2. Snowwind for munch 2, and then Cascadia for sugar snap. And basically, the crop is a winter crop. It does very well if you grow it under cool conditions. It doesn't do very well when it's very hot. And then you also have a lot of pest issues when it's warmer. And we plant this crop after following baby corn, because previously we were using a lot of poles to try and support the crop, because you have to trellis the peas for it to grow very well. So at least we came up with something that is working better for us instead of using poles. Now, for pest monitoring, we've actually been working hand in hand with our colleagues that come here to monitor, the plant health inspectors. They do come here every 2 weeks to come and check in the field. They do the scouting, and if they find any issues, any problems, then they'll give us an advice on how to go about it and show us the presence of those insects.
The process of receiving peas here at York Farm begins at intake. At intake, what we do when the product comes from the farm, it is weighed through the scale, and then from there, random samples are picked by the QCs who bring them to the assessment table. At the assessment table there, the main objective of that assessment table is to ensure that the defects that are found in the sugar snap have been assessed. So we assess the sugar snap based on the customer specifications. These customer specifications, they will show the defects that are not supposed to be found in the product that has been received. And these specifications are pasted on the walls just for the QCs to see what they need to look out for in a product. So the next stage after the product has been received at the receiving area, it has to be taken into the raw material code room. And from the raw material code room, it is issued into the lines, into the packing hall, like what you saw. And there the process is a sorting of the product. It has to be sorted according to the customer specifications. And any defects that have been found in a product are supposed to be isolated. Only the best product that complies to the customer specifications is packed. And once that is done, the product is taken into the dispatch code room. And there it is boxed and palletized, ready for dispatch. It is at that point where the PQPS comes in to assess the product.
So here what we do when we conduct inspection here at York Farm, this is where the final inspection is done, apart from the inspections which are done in the field. So what we do here is that we inspect the final produce before it's loaded on the truck for export.
And I'm going to introduce the different labs that we use in the identification of plant pests. For insects, the entomology lab is responsible to identify all kinds of insects. For fungi, we have the mycology lab. In addition to the mycology lab, there's also the general plant pathology lab, which is responsible for identifying different kinds of pathogens, such as the fungi, the bacteria, nematodes, and viruses. In addition, we have the molecular lab, which use DNA-based methods to identify plant pests. This is the mycology lab. The main objective of the mycology lab is to identify plant pests, to generate pest data, to carry out seed health testing, to certify referred samples from exported and imported plant materials against pests, and also to test the plants, plant products, and other regulated articles for phytosanitary purposes. All samples that are collected from farm, nursery, seed crop inspections, import and export inspections are delivered to the lab for analysis in order to identify the pests which could be associated with them. In the mycology lab, we have different kinds of equipment which are used to identify plant pests which are associated with the plants, plant products, and other regulated articles. These are microscopes that we use. This is the stereo microscope, which is used to view the incubated plates, and this is the compound microscope, which is used to identify the spores, the different kinds of spores that are associated with the plants which are infected. This is the laminar flow, which ensures that the diagnostician works in a sterile environment to prevent the contamination of samples during the isolation process. This is the autoclave, which is used for autoclaving apparatus and medium so that they are free of any contaminants. These are weighing balances that are used to weigh reagents as specified in the isolation procedures and protocols specific to the particular pathogens that are associated with the plants and plant products.